Hello and welcome to Sensing Planet Earth from Core to Outer Space. My name is Thomas Hobiger, and together with my colleagues, I will take you on a virtual tour that shows you where, how and why we measure our planet. In this course, we will look at different areas in, on and above the Earth, and we will try to identify crucial parameters or phenomena at such locations. We will then see how we can measure those. We will start with basic measurement principles, learn a little bit about the underlying physical principles, and then see how we can use those to develop great tools for sensing our planet. You will see that such instruments can be very simple, like a thermometer, or they can be complex systems like satellites. But first, let's ask ourselves, why do we measure planet Earth? Well, there are plenty of reasons. It has always been important for us humans to observe, understand, interpret and even predict phenomena in our environment. Why? Well, some of those phenomena can affect or even harm us. So it has always been of utmost importance for our survival to understand our environment well. For instance, we can quite safely assume people living in the Stone Age were already well aware that locations next to volcanoes or areas with frequent earthquakes were not the best places to establish new settlements. Another example is that people started to make weather forecasts. They found out that it's useful to observe how air pressure changes and then forecast sunny or rainy weather. Together with rather practical reasons, we humans have also been driven by curiosity. For example, realizing that we can't drill deeper than just a few kilometers in the Earth's crust, people searched for other ways to find out what Earth might look inside and its composition. Therefore, instruments and sensors were developed over the centuries with the sole purpose of observing the Earth. But first, let's go back to the very basics. What is measuring? Well, strictly speaking, it's all about assigning a number to a certain characteristic of an object or event. For instance, let's take the simple example of measuring length. Assume that you have an ordinary ruler. The separation of two long marks is a measuring device feature which you could use to measure the object of interest. All you need to do is to count the number of these features that matches the object you want to study and then assign that number to the object characteristic. You can use the same ruler to measure two different objects. For example, you can determine which one is the longest just by comparing the numbers that you assign to the objects. This might seem obvious, but it's of fundamental importance in science. Since there is an infinite number of ways to define a measurement device feature, we must agree on common features. In that case, we speak of units rather than of features. Let's take the example of measuring height. As you know, meter is the corresponding unit. So if someone says the mountain is 120 meters high, what actually means is that the mountain is high as 120 times the defined unit called meter. Now the next question is, how many of these units are available and which types of units do we need? Again, there's an almost infinite number of units that could be used. Let's continue with the unit of length as an example. We could use meter, inch, feet or other features which are either historically motivated or set by big improvements of physical theories and engineering skills. As for earth science and science in general, confusion can be avoided by agreeing to use the International System of Units, abbreviated as SI units. The International System of Units consists of just 7 so-called base units, which are shown here. The 7 basic units include meter, kilogram, second, ampere, Kelvin, candela and mole. These 7 units are enough to express any physical property we measure either in basic units or as a combination of basic units. For example, we measure length or distance in unit of meters, and we measure time in units of seconds. We can combine these two units to define speed, which is the distance or length per time unit. We get the unit for speed, which is meters per second. By the way, Several of the 7 basic units trace back historically to the study of the properties of the Earth. In particular, units for length and time were based on the size and rotation speed of our planet and only got replaced by other definitions in the second half of the last century. So measuring and sensing planet Earth also determined the units for our daily life. So when you tell the time, remember that the second originally was 1/8604 of a day. Thanks for signing up and watching. I'm looking forward to explore more about sensing Earth together with you in the next weeks.